Okay, so in a circus act, a 60 kg clown is shot from a cannonball with an cannon with an initial velocity of 16 meter per second at some unknown angle above the horizontal, and a short time later the clown lands in a net that is 3.9 meter vertically above the clown's initial position. So we can disregard the air drag. What is the kinetic energy of the clown as he lands in the net? So basically the clown is shot maybe at this angle, and let's say the net is somewhere there, so he goes that way and then lands here. So this angle we don't know, but we will consider just the energies there. Since there is no air drag or any other kind of energy loss, we will consider the mechanical energy to be constant. So this height, the final height, is 3.9 meter more than the initial position. So when the clown lands on the net, this is, let's say this is the net, let's say, I don't know, like that. So he has a greater potential energy than he had here, so he gains a potential energy. So let's say initially the kinetic energy is KEI, and the potential energy initially, let's say 0, because we will just consider these two positions. This is position A and this is position B on the net. So considering that B has a higher potential energy with respect to A, so let's say A doesn't have, the potential energy is 0, let's say, only then we can give a positive value to B with respect to A. So that's the kinetic energy initial. And finally there is a potential energy because he has gained some height, so that is P final plus KE final. So we have to find KE final basically, because that's the, what is the kinetic energy of the clown as he lands in the net. So KE, we can now rewrite this like this: KE final equals to, KE initial minus PE final. So KE initial is half into mass into velocity square, and PE final will be m into g into height, which is height BA. Let's say that's BA. So height between A and B. So mass is given 60 and initial velocity is given. We don't need the angle, the velocity is enough. The velocity is 16 meter per second square, and then m is here again 60 into 9.8 and into this is 3.9. I get 5.387 into 10 to the power 3 joules. So that's the kinetic energy, or we can write 5.4 kilojoules maybe. So that's the final kinetic energy of the clown. So we could calculate also the velocity, the final velocity with the velocity with which he lands. So that will be, from using this one, equals to half mv f square. So if I call it vi initial, that would be f. So yeah. So basically we have assumed that mechanical energy is constant, and mechanical energy is the sum of kinetic energy and potential energy. So that stays constant. That means whatever the sum of initial kinetic and potential energy, that will be equal to the final value of kinetic energy and potential energy, and any intermediate value as well. The sum of potential energy and kinetic energy is constant. That's what we have assumed, and that's a fair assumption because the air drag is said to be negligible and no other loss is mentioned. So we can assume that the mechanical energy is constant throughout.